Hi, Professor. This is Dan Riseman with section 1.1, the assignment. For number 20, what I did is I used the midpoint formula, x1 plus x2 over 2 and y1 plus y2 divided by 2. I got the midpoint from problem 19, which is negative 3, 2. From there, I used the distance. I used the distance formula, square root of y2 minus y1 squared plus quantity of x2 minus x1 squared. And in doing so, I got radical 13 was the distance from negative 3, 2 to the origin of 0, 0. I then did the distance formula again from negative 3, 2 to negative 6, 4, and doing that I got radical 13. So since the distances from the midpoint, negative 3, 2, is radical 13 away from both endpoints, it is verified that that in fact is the midpoint. Number 21. Explaining why midpoint of a line segment must line the line segment itself. Well, since the midpoint of a line segment is the point that the segment that divides a segment into two congruent segments, the midpoint must lie on the segment itself. The midpoint is the point on which the segment itself that is halfway between the endpoints. So it's basically a point. The midpoint is a point on the line, on that segment, and because it's in the middle, it divides that segment into two equal parts. From one endpoint to the midpoint and from the midpoint to the other endpoint, that would be the definition of the midpoint. So it must lie on the line. Number 22, which I like this question. You have x1 and x2 and y1, they're all greater than 0. And because of that, we shift over here. Quadrant 1 is going to have positive x's and positive y's, and quadrant 4 to have positive x's and negative y's. But all your x's are positive, so they all must be in either quadrant 1 or quadrant 4. And it's only going to be in quadrant 4 if we have a negative y. Now, we can have that negative y based on the fact that y2 can be less than 0. So because of the situation, you could have quadrants 1, it could be in quadrant 1, it could be in quadrant 4, but it's not going to be in quadrants 2 and 3. No way can it be in quadrants 2 and 3 because your x values are always positive. And you can see the numbers I picked. In one example, I picked 3, 5, and I picked 1, negative 2, and in doing so, I got the midpoint of a value of 2, 3 halves, quadrant 1, and then I did another example with points 2, 1, and 5, negative 10, and doing so, I got the midpoint of 7 and negative 9 over 2, quadrant 4. And for 23, I like this question. You have two line segments, AC and BD, and they're going to share a midpoint. Well, there's a couple things you can get out of it, a couple quadrilaterals you can get. You can get a parallelogram. These opposite sides are congruent and alternate interior angles. And there's your midpoint, subdividing these lines and sharing because midpoint would be the same for both. Same thing with a rectangle. This is equal to that, congruent to that, that's congruent to that. 4 right angles, and you can see that would be the midpoint. A rhombus, all the sides are congruent. Right angles here in the center where they bisect and forming the midpoint right there, and a square. All 4 right angles, all sides are equal, and the diagonals come together. Right there is your midpoint. I erased here, I erased the fact that an isosceles trapezoid, it does not work. I tested it and does not work, and that would be one of the problems I added to my set. Thank you. It was good work. I appreciate it. It was fun to do. And let me know if you have any questions. Thank you.